everybody. Today I'll be going over how to calculate a binomial probability using a TI-83. Now, a binomial probability is a probability that has a set number of trials that are independent and have only two possible outcomes, which we usually label as successes and failures. Once I've identified that I have a binomial distribution, then I can find three important numbers that I need to substitute into my calculator. These include my number of trials, N, my probability of success, P, and my number of successes, X. Because the binomial distribution is a discrete probability distribution, whether or not I include X is important for my calculations in my calculator, which means that I have 5 possible scenarios and 5 possible ways that I can substitute my numbers into my calculator. These scenarios include equals, less than or equal to, less than, greater than, and greater than or equal to. If I am calculating the probability that X equals a number, then I'm going to use the PDF function in my calculator. But if I include any inequality, I am going to use the CDF function instead. Both the binomial PDF and CDF functions can be found in my distribution section of my calculator. To get to that, I can press second and then vars and scroll down to either binomial PDF 0 or binomial CDF A. Both the binomial PDF and CDF function in a TI-83 require that we find our 3 numbers and separate them in order N, P, X in the calculator. The comma can be found above 7 on the calculator. For each of my 5 scenarios, I can use how I substitute my numbers in my calculator as a preview for the scenario itself. For equals, I need binomial PDF, parentheses, N, P, X, close parentheses. For less than or equal to, I need binomial CDF, parentheses, N, P, X, close parentheses. For less than, I need binomial CDF, parentheses, N, P, X minus 1, because I am not including X in my calculation. And for greater than and greater than or equal to, I need to calculate the complement of my probability. So for both of these calculations, I will need to do 1 minus my binomial distribution. So for greater than, I need 1 minus binomial CDF, parentheses, N, P, X, close parentheses. And for greater than or equal to, I need 1 minus binomial CDF, parentheses, N, P, X minus 1, close parentheses. Now I can either do the 1 minus before I plug in the binomial distribution, or I can calculate the binomial and then subtract my answer from 1. Both would give me the correct answer. Now, I am going to go over some example questions to show what this might look like in a real problem. For my scenario, it says, suppose that Carlos is taking a multiple choice test with 15 questions where there are 5 answer choices, and he randomly guesses on them. Before I can calculate my probabilities, I have to first determine, is this a binomial distribution? So first, do I have a set number of trials? Yes, I have 15 questions in my test, which means I have 15 trials. Are my trials independent? Yes. Whether or not I get one question right on this test does not change whether or not I'm going to get another question right on this test. And do I have 2 possible outcomes? Yes. While there are 5 answer choices for my questions, the only possible outcomes that I have are if I get the answer correct or the answer incorrect. Since all 3 of my conditions are met, I can say that this is a binomial distribution, which means now I can identify my 3 important numbers for each of my sections. My number of trials, n in this case, is 15, which I identified earlier. My probability of success, the probability that I get one answer correct by guessing, is going to be 1 out of 5, because there are 5 possible answer choices. And then for part A, it says, what is the probability that he gets exactly 3 of the questions correct? Which means that I am calculating the probability that x equals 3. I can write this in probability notation by saying p parentheses x equals 3, close parentheses. This allows me to write shorthand the probability that, parentheses, x equals 3. I can then match this with one of my 5 scenarios. In this case, since I'm calculating the probability that x equals 3, I know that I'm going to do my PDF function. So in my calculator, I will click second, bars, and scroll down to binomial PDF. Then I will type 15, comma, 1 out of 5, comma, 3, close parentheses. For my p, I can either type in the fraction 1 out of 5 or the decimal 0.2. Both would work just fine. I can then double check to make sure that my calculator looks like my preview. So I see binomial PDF n, comma p, comma x. Then I can press enter, and I can see the probability that x equals 3 is 0.2501. For part B, it says, what is the probability that he gets at most 6 of the questions correct? Now, at most is the same as less than or equal to. So in my probability notation, I can say that I'm trying to find the probability that x is less than or equal to 6. And I can use my second option for my preview. So in my calculator, I will press second, bars, and scroll down to binomial CDF. Then I will type 15, comma, 1/5, comma, 6, close parentheses. And I can double check that this matches my preview of binomial CDF n, comma, p, comma, x. And I can see the probability that he gets at most 6 of the questions correct is 0.9819. For part C, it asks, what is the probability that he gets fewer than 5 of the questions correct? So in this case, I am trying to calculate the probability that x is less than 5. So I can use my third scenario. I can go ahead and press second bars and scroll down to binomial CDF. Then I can type 15, comma, 1/5, comma, 5 minus 1. Because I am not including the number 5 in my probability. I will note here that I could type 5 minus 1, or I could just type in the number 4. I personally like to make sure that it looks exactly like my preview, so I don't have to forget anything, but I could have also just typed in 4. Then I can double check that my binomial distribution looks like my scenario. So this is binomial CDF, parentheses, n, comma, p, comma, x minus 1. Then I can press enter, and I can see the probability that he has fewer than 5 of the questions correct is 0.8358. For part D, it asks, what is the probability that he gets more than 4 of the questions correct? This question is greater than, so I'm calculating the probability that x is greater than 4, which means that I need to do the complement of my probability. So I will type 1 minus, and then do the second bars and the binomial CDF. My n is 15, comma, my p, 1 out of 5, comma, my x, 4. I can double check to make sure this matches my preview for greater than. So in this case, I have 1 minus binomial CDF n, comma, p, comma, x. And I can see that the probability that he gets more than 4 of the questions correct is 0.1642. And last but not least, for part E, I am asked, what is the probability that he gets at least a majority of the questions correct? Now, this question is a little bit harder than the other ones because it does not give me x directly in the question. Instead, I have to find x and then pick my scenario that I have. Now, a majority of something is going to be more than half. Since I have 15 questions in my test, more than half of those would be 8. So the probability that I am trying to calculate is the probability that he gets at least 8 of the questions correct. Just like how at most is less than or equal to, at least is going to be greater than or equal to. So we are trying to calculate the probability that x is greater than or equal to 8. Which means I will be using the last option for my scenarios. Just like greater than, I need to do the complement. So I'll type 1 minus, and then do second bars, binomial CDF. 15, comma, 1/5, comma, 8 minus 1, close parentheses. And I can double check that this matches my preview. I can see it says 1 minus binomial CDF n, comma, p, comma, x minus 1, close parentheses. So I can see that my probability that he gets at least a majority is 0.0042. And that's how you calculate the binomial probability using a TI-83. I hope you have a great rest of your day.